All right, A-48. I'm going to, you only have 10 problems, so once again, I'm only going to do 2 of them, because that leaves you, with 8 you have to do by yourself. And hopefully in class we had a chance to do a couple as well. So I'm going to graph y is equal to x. So once again, y is already isolated, so it is in y equals mx plus b form. So I can rewrite this equation as y is equal to x plus 0. And then I could even go so far as to say y is equal to 1x plus 0. Therefore, my y-intercept falls right out. It's 0. So let's go ahead. Let me go ahead and graph some axes here. So let's say, there we go. Okay, so therefore, when I come back and grab my blue, and I graph my y-intercept is 0, it's right there. So it's on the y-axis, and the x value is 0 there. So I've graphed that, and now my slope, which, as I say every time, is the change in y over the change in x, and that's equal to 1 over 1. So I go up 1, that's my change in y, and over 1 in the right direction, because that's also the positive direction for x, and that's my change in x. And up 1 over 1, up 1 over 1, up 1 over 1, 1 over 1. All right, so I think you get it, and I get this line here that comes right through here. And that's my line, y is equal to x. And now I'm going to go ahead and switch pens, grab the orange one. And in this case here, once again, it's in y equals mx plus b form, or slope-intercept form. And this time, my y-intercept is equal to 1. So let's go ahead and graph that point. So it's that point right there. And now my slope, which is my change in y over my change in x, is equal to 2, and I'm going to write 2 as 2 over 1, because then I can see better what I do in the x direction. So from this point, I go up 2 over 1, up 2 over 1. So that means, if I continue, and I have this line that goes right through here. Okay? And then I notice that, if I find the point where they actually intersect each other, that point where they cross is right there. And the value of that point is going to be negative 1, negative 1. So now I'm going to go ahead and make sure that that satisfies both equations. So if I come back over here and I take a look at, the equation y is equal to x, the question, I'm sorry, what am I have no idea why I stuck a negative there. When I come back over here and I have y is equal to x, if I plug in this point here, right, I'm going to plug in the point negative 1, negative 1. Therefore, my x is negative 1, my y is negative 1, and, sure enough, that satisfies that equation. Check, it satisfies it. That's a horrible check mark. Check, there, it is. And then if I plug it into the other one here, where I have y is equal to 2x plus 1, once again, I'm going to, make sure that the point negative 1, negative 1 satisfies that equation. So that's going to give me, my y is negative 1, and then that's equal to 2 times my x, which is negative 1 as well. And then, I have a plus 1. So I end up with negative 1 is equal to negative 2 plus 1, which gives me negative 1. So I end up with negative 1 equals negative 1, and it checked in that equation as well. So I know I'm right. All right, one more. So this is number 8. So I'm going to graph system of equations, 2x plus y equals negative 5, and y is equal to negative 2x plus 5. So in this particular case, I'm going to start with the purple one because it's already in slope-intercept form. So my y-intercept, I don't even have to do anything, is equal to 5. So I'm going to come up here, 1, 2, 3, 4, 5. There it is. And now my slope is equal to the change in y over the change in x, and that's going to be negative 2, and I'm going to write it as negative 2 over 1. So that means in the y direction, I'm going to go down 2 because it's negative, and then my x is 1. And then I'm going to go down 2 because my y is negative 2, my x is 1. Down 2 over 1. Down 2 over 1. I have that point, that point, that point. I connect my happy little dots, and there they are, and there's my line, and that makes sense, right? Because I got a negative slope. Then I'm going to come over here. I'm going to grab an orange pen this time. Now y is not by itself, but all I have to do is subtract 2x from both sides. And once again, those are gone, and I get y is equal to, and just for consistency's sake, I'm going to write my negative 2x first, and then I have a minus 5 left. So now my y-intercept is equal to negative 5. So I'm going to go down 1, 2, 3, 4, 5. There it is. And now my slope is negative 2. So that gives me my change in y over my change in x, and I'm going to write that as negative 2 over 1. So I'm going to go down 2 over 1, and in this case here, that's going to be, go. So from this point, right, to this point, I went down 2 over 1. I went down 2 over 1. I went down 2 over 1, come on. And there is my line. Well, I notice, right, that these two lines are in fact parallel. Okay, so I'm just choosing a different color for the fun of it. So my lines are parallel, right, because they have the same slope and different y-intercepts. Y-intercepts. Okay, you guys, so there is no, so they have no intersection. No intersection. I'm going to run out of room. No intersection point. Alright, so there is no place that they intersect because, in fact, they are parallel. Okay, alrighty, guys, that's it. I'm not going to do another one. No, you guys are sorry. I'll see you tomorrow.